Alright guys, this is the beginning of lesson 6.2. This will take us a couple days and several videos, so we'll just do this piece by piece. And you've got a bit of a long packet there with 16 slides in it. And so just kind of be patient with it. We'll go through it step by step, and each step hopefully will make sense, and you'll put it all together and look back, and you'll be able to do some very, very tricky trig equations here. So we're going to solve trig equations in this section. And before we do that, I want to remind you, we're going to keep coming back and forth with it. I remind you just solving algebra equations before we do the trig. And so I'd like to do that first, then we'll jump to a trig equation, then we'll come back into another algebra equation. Just kind of come back and forth like that. Okay, different kinds of algebra equations. And the first kind of algebra equation you ever dealt with would have been back in freshman algebra. And it's a linear equation. You know it's linear because when you look at the powers, look, it's a first power. And usually you're used to x's, but here there's y's on both sides, no big deal. And whenever you have a linear equation, you want to get the letters on one side, and you want to get your numbers on the other side. So the variable on one side, combine like terms, and get your number on the other side. So if you're doing this problem, you're going to go 3y plus 4. The right side you distribute, you get 8y plus 16. You notice you have y's on both sides. You don't want that. What I used to tell my algebra students is you pick on the little guy. So since 3y is smaller, from both sides I'll subtract 3y. We'll continue this up here. On the left side, you see I have just a 4 because the 3y's cancel out. The right side, it looks like 5y plus 16. We'll take off 16 from both sides. So negative 12 is 5y. We'll divide by 5. And I get negative 12 fifths, or negative 2.4 if you want a decimal, equals y. Okay. Things to notice. What was our method? Get the variables on one side. Look, you can see that right here. Get your constant or get your numbers on the other side. And the other thing to notice is when you're done, you get a single answer. Okay, now let's contrast that with a trig linear equation, kind of the analogous trig, but it'll be a linear equation. So let's skip through all the algebra for right now. And we're looking at this problem, which is on slide 5 here. And we've got, a couple of these. Nice. Okay, so we're going to use these same principles that we just, for your algebra principles, now with trig equations. And I'll notice here I have a trig function. So instead of a y, I've got this whole thing of the tangent of x. But I'll notice is tangent of x to the first power. If you look through here a little further, you see, oh, wait, later on we're going to get second powers. Or, who knows, maybe we'll get third or fourth powers. But because it's a trig function to the first power, I'm going to treat it just like a linear equation when I was solving algebra equations. So what does that mean? That means get your variable, which is now your tangent of x on one side, get your constants on the other side. So step 1 on this, take off 1 from both sides. 2 tangent of x is negative 2. Step 2, divide by 2, so tangent of x is negative 1. And now I want to solve this for x. And here's where section 1 comes into play. I want an angle. So the tangent of what angle equals 1. So I can really, if I want, let me write it over here. I can think of this as taking the tangent inverse of both sides, if you want to think of it that way. And on the left side, the tangent inverse of the tangent cancels out. So x is the tangent inverse of 1. Oh, I'm sorry, of negative 1, isn't it? That's a negative 1 in there. And so now as you think through this, it's like, wait, that was section 1 that we just did. And in section 1, I was okay for a while using your unit circle. Eventually you want to become independent of that unit circle. I didn't recopy your unit circle, so you may want to pull out your packet from 6.1. I do have a copy here at the end of the notes, hopefully. Here it is. Look, it doesn't have all those typos on it from the first one. And so I'm looking at this unit circle. It's like, oh, shoot, I don't even have the tangents on here. But you should remember. We've done this enough. This is root 3 over 3. This is 1. This is root 3. And you'll have the analogous ones over here. So I want the tangent inverse of negative 1. Would you guys agree that the tangent inverse would be negative right here in the second quadrant? In the fourth quadrant, because A smart trig class. And where would it be negative 1? Well, let's see here at 1, it's at pi fourths. So we're looking at 3 pi fourths, or 135 degrees. We're looking at 7 pi fourths, or 315 degrees. So I come back What was the tangent inverse of -1? Come back here. That's a long ways back, isn't it? What's the tangent inverse of -1? Look at this now. I get two answers. It says on the interval between 0 and 2 pi, so using that interval, they mean use radians. If they said between 0 and 360, we give them the degree answer. So our two answers are going to be x equals 3 pi fourths and 7 pi fourths. All right, so things to notice. It was a linear equation. We got the tangent alone, or we got rid of the tangent, did the tangent inverse. We got the tangent on one side, got the number on the other side. And for a linear equation, look at this. You get two answers instead of one answer. All right, so the approach is the same, but just know in a trig one now, instead of one answer, you get two answers. Let's try it again. Here's 2 cosecant of x plus 1 equals cosecant of x plus 3. Okay, I want my variable, I want my cosecant of x on the same side. So I'm going to subtract a cosecant of x from both sides. 2 minus 1 is 1, so I have 1 cosecant of x plus 1. Over here, the cosecants cancel out, so I'm left with the 3. I don't really need that first one, so the cosecant of x, if I take off 1 from both sides, equals 2. I'm not so good with cosecants, so I'll take the reciprocal. The reciprocal of cosecant is sine. The reciprocal of 2 is a half. So where does the sine equal a half? And again, if you want, you can write that, the sine inverse of a half, if you'd like. Or, I think it's just as easy here. Where does the sine equal a half? Let's come back to that unit circle again. Sine. Sine was the y-coordinate. Let's erase all this other stuff that's on here. So where's the y-coordinate a half? And again, we're kind of expecting two answers now. Get that out of your way. Get that out of your way. Where was the sine? Where was the y-coordinate a half? Oh, look, right there. There's one answer. And I'll look in the second quadrant because A smart. The sine's also positive there. And I'll give those two answers. So again, a linear equation for a trig function, you give two answers. And my two answers are pi 6 and 5 pi 6. If you're using your unit circle, that's fine at this point. If you're not, much, much better. But those would be my two answers. X equals pi 6 and x equals 5 pi 6. All right, not a bad start. Let's pause this here. In our next video, we'll talk about quadratic equations.